systems that are coming, that are at least being considered, that have hundreds or even thousands of satellites that will require a wholesale reallocation of bandwidth from existing uses to their uses. So it's a very difficult and challenging process, and I'm sure it keeps you awake at night.
Yeah, yes, it does. I would like to, given the short time remaining, I would like to give the floor, open the floor for the audience if there is any questions or any comments that they would like to give. Please, Mr. Abdulaziz.
Yes, I have a question for Mr. Tony. To reach 40 kilowatt, what you doing with the solar? Are you putting more panels, higher, I don't know, what new solar array, so how are you reaching that one? And what your estimation of the weight of the satellite will be, and everything. You know,
Understood. Okay. It's a complicated question, a very good question, but a complicated one. So in terms of solar arrays, we're moving toward continually higher efficiencies of solar cells, and so that enables you to have smaller array for the same power. We're moving now through about 30% efficiency, and we'll be, approaching the high 30s by the time that we deploy a 40 kilowatt satellite. Satellite mass is being reduced, so mass efficiency is increasing, and that's particularly coming in the payload areas as well as in the bus. So I don't expect that a 40 kilowatt satellite would weigh twice as much as a 20 kilowatt satellite. It might weigh 50% more or 60% more. And the solar arrays might be 50% larger or 60% larger, not twice as large.
So it's around 8 tons?
It's going to be driven very much by the application, by the type of satellite, but I think that's a fair estimate, yes.
Okay. And for her, I don't know, this data you're sharing with anybody, or is just 50, 40?
The data of the experiment?
Yeah.
Yes, naturally, the payload has been funded by the Italian Space Agency and is hosted inside a European Space Agency platform. So this is the results, some of the results are being published in papers. There is a very light process. I am the PI, so I reply to my space agency. I just submit what I want to publish, and is granted, because naturally this is funded with public money. And so it's also a transparency matter that the result will be shared, and in order not to duplicate experiments and to start from the place we arrive. So naturally there is a process from which the data can be shared through this very simple and very obvious publication procedure. Oh, by the way, I would like also to tell you that there is an historical conference that is called K-Band Conference. It's jointly organized between American people and people from the Marconi environment, so from Bologna in Italy. This year, it will be in Bologna this year, exactly, in October. They asked me to make a special session on 1 year of result of this experiment. And so maybe I will maybe I can let you know about this conference. I will communicate with the panel chair, because this is a good opportunity to see some of the results also in a public form. AlphaSat. Tony.
You're talking about the next generation of a high throughput satellite? Yes. I mean, as we've discussed here today, the satellite is just a node in a network, and in that sense, if the communications point is on the surface of the Earth, it's a bent pipe, up and back down.
I'd like to have the last question from the speaker.
Regarding the X-band, how you will see the future of X-band for the high throughput? Any special techniques or modulation can be employed to increase the bandwidth of the X-band, especially for some military application?
Well, I think X-band, I'm not 100% sure I understand the question, but I think there are two parts. First part is the regulatory part, and so the X-band, I believe, is secure at this time. I don't think we anticipate any immediate transfer of that spectrum to other uses. And then in terms of throughput, really it's driven by requirements. The throughput of a satellite operating in X-band can be very large. Could be 100 gigabits per second, depending on requirements. And so beam size and power levels and other technical characteristics could be such that it could have a very high throughput. It is technically possible.
Any current application to utilizing the X-band with higher throughput?
We don't have anything that's being built today that does that, but there's nothing to prevent it. It's feasible, it's possible. I actually think the main, I'm not 100% sure, but I think at X-band you may come to regulatory issues because of terrestrial use of X-band, so there'd be balancing of power levels and isolation levels would probably be the next factor.
Well, the X-band is basically used by the for government uses. So even for the new allocations, it's a terrestrial use and the space use, but all of it, even the studies are made, it's all of it for the government use. But with that, I think I'd like to close this panel. I think it's a very interesting topic, and I would love to continue more and more. But thank you very much for listening, and I hope you had an informative time. And thank you very much for our panelists.